Hello and welcome. Today we have a question on water hardness. So let's read the question. In an experiment to test for hardness of water from different boreholes, soap solution required for lather to start forming were recorded. The results are given in table 2. This is table 2. We have water sample in 1000 centimeter cubed, volume of soap solution in centimeter cubed before boiling and after boiling. So we have from sample 1 to 5. Then the questions are: A. Select water sample that shows temporary hardness, half a mark; no hardness, half a mark; both temporary and permanent hardness, half a mark. So before we answer this question, I want us to just have a short review about what water hardness is. So as you see, this is something like a graph. We are seeing water, we have soft water and we have hard water. So soft water is water that easily lather with soap. So we are saying soft water is water that easily lather with soap. In other words, when you mix it with soap, then we have hard water. So hard water is water that does not easily lather with soap. So hard water we are saying is water that does not easily lather with soap. Then we see hard water here, it is divided into two. So we have temporary and we have permanent. So we are saying we have, after hard water, we have two types. We have temporary hardness and we have permanent hardness. Temporary hardness is a type of hardness that can be easily be removed by boiling. But permanent hardness, it requires more complex method to remove it. So after that, we go to advantages of hard water. So we have some advantages of hard water. I've just listed 3 of them. So is hard water is used in beer brewing. Hard water is used in beer brewing. We are saying hard water is used in beer brewing. Then the other advantage is hard water provides calcium, which is important in strengthening of bones. So hard water, it has a, because when you go to the example, you find that we have calcium. So calcium is important for the strengthening of our bones. So we are saying calcium is important in strengthening of bones. Then the last advantage is hard water does not dissolve lead pipes in lead metals. We are saying hard water does not dissolve lead pipes. Okay, let's go to the disadvantage. Disadvantages of hard water, we also have 3 of them. The first one is hard water waste soap. In other words, we require a lot of soap for you to wash using hard water. So we says one of it is it wastes soap. The other disadvantage is hard water stains white cloth because it forms a scum on the white cloth, so it stains it. So we are saying hard water stains white cloth. The last disadvantage is deposition of FAR. This is calcium carbonate in kettles. So we are saying deposition of FAR or calcium carbonate in kettles. Then after that, we are going to method of removing water hardness or hardness of water. We have 6 of them. The first one is boiling. So boiling only removes temporary hardness. Boiling only removes temporary hardness. The second one is use of ammonia solution. So the second one is use of ammonia solution. The third one is distillation. So we are saying the third one is distillation. The fourth one is ion exchange resin. Use of ion exchange resin. Okay, the fourth one, I want to say something about it. Ion exchange resin remove both temporary and permanent hardness. Ion exchange resin remove both temporary and permanent hardness. So the fifth one is use of calcium hydroxide. And the last one, number 6, is use of sodium hydroxide. Sorry, we are saying the last one is use of sodium carbonate. Then after that, now we go to examples of soft water and hard water. We have examples of soft water and hard water. So examples of soft water, we have 2 of them, and example of hard water, we also have 2. So the examples of soft water, we have zinc and we have sodium. Hard water, we have calcium and we have magnesium. So we have that as a graph on water. So let's go back to the question. The question is, select water sample that shows temporary hardness. In other words, hardness that after boiling it is removed. So when you go back to the table, you'll see that number 1, we have 25 centimeter cubed of soap solution. After boiling, use 3. So that basically tells you that temporary hardness is number 1. No hardness. In other words, there was no difference between boiling and after boiling because there's no hardness. And when you look at number 3, we have 10, 10. Number 4, we have 3, 3. That means we choose number 4 because it requires little soap. So yeah, little soap to leather. So we are saying this number 3. Then both temporary and permanent hardness. When you go back to the table, you'll find that number 5, you have 24 before boiling and 25 before boiling and 24 after boiling. That is to tell you that in this one, even though there is a little bit change, but it means there's permanent hardness in it. So this little change symbolizes temporary hardness. So we are saying this number 5. Part B of the question, we are saying describe how water hardness can be removed using an ion exchange resin. I've said something about ion exchange resins that it removes both temporary and permanent hardness. So this is how it looks like. We have sodium ions, sodium ions, sodium ions. Then you pass the hard water, which has calcium or magnesium ions. After you pass it through this is the ion exchange resin. So the calcium and sodium ions will be attracted to the will be absorbed in the ion exchange resin, and after that sodium water with sodium now will pass through the ion exchange resin. So this is how it happens. After you pass the water, you'll find that the calcium ions remain in the ion exchange resin, while the sodium ions now get out. So we'll find in the water, because it contains sodium, that means it will be soft water after that. Now the calcium ions or magnesium ion, depending on which water hardness you use, will remain in the ion exchange resin. So that is exactly how the ion exchange resin works. Thank you and welcome. Simply we are saying hard water is passed through a column with some complex sodium compound, which can be represented by sodium X, where X is complex. So we can try to write an equation like this: sodium X plus, now this is the hard water. Now we remain with calcium X plus sodium ion. Now because sodium is soft water, now it will be passed through here, while the sodium calcium ions are absorbed here. So we finally get soft water.